Hi, today we're going to be explaining section 3.5, problem number 14. And the object of this problem is to make a proof and conclude that angle BYZ is congruent to angle CZY. And so there are a couple ways to go about doing this problem, but our group chose to do it using the addition property. And so we found that angle CZE is congruent to angle BYE, and angle DZE is congruent to angle DYE, and you can use those and add the two congruent angles to find the larger angles congruent.
So this is our proof, and we're going to start with step 1, which is YD is congruent to ZD, and so we'll make a mark of that. And our second given is E is the midpoint of YZ. And the definition of a midpoint is it divides a segment in half, which is step 3. So we know that YE is congruent to EZ. And then our fourth step is going to be, we're going to draw in DE. And 2 points make a line, which is our reason. And then DE is congruent to DE because of the reflexive property, which is a segment is always congruent to itself. And in step 6, we're going to prove that DYE is congruent to DZE because of side, 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 which we showed in steps 1, 3, and 5. And because we know the two triangles are congruent, we know that DYE is congruent to DZE, which is CPCTC.
Next, we are going to prove CZD and BYD congruent. So first, we know from the previous problem that YD is congruent to ZD. And then we also know that BD is congruent to CD because that was a given. We also know that angle BDY is congruent to angle CDZ because vertical angles are congruent. So that proves these two triangles congruent because of side angle side, which was steps number 1, 8, and 9. And it also proves that angle BYD is congruent to angle CZD because of CPCTC.
So using what we learned, knowing that these two smaller angles are congruent, we can use the addition property. So when you're adding two smaller congruent angles, the larger angles that they make will be congruent, and that's your conclusion.